Hi guys, welcome to another Learning Electronics Repair video. I have here this little gadget. It's an Espotek Labrador. This was sent to me by PCBWay.com. PCBWay are kindly sponsoring this video, and they produce PCBs and have a range of other services for hobbyists and production runs of PCBs. They make enclosures, 3D printing, and a number of other services they have. One of the great things about the sponsorship deal I have with PCBWay for Learning Electronics Repair is it gives us an opportunity to make our own little gadgets. I've started a section on the Learning Electronics Repair Discord server, and there's a few guys on there already coming up with some suggestions of things we can make in the way of test equipment to make life easier for repair work. And if you want to get involved in that, just get over to Discord. I've set a target for the end of May to get some suggestions in. We have some already, and then make some decisions on what we're going to work on first, or we may work on more than one project. And again, PCBWay.com are very happy for us to do that and will assist us. So enough about that for now, but let's have a look at this little gadget and see if this is something we can use for repair work. I'll give you a little bit of information about the Espotek Labrador and show you what it's intended to be used for, and then let's see if we can modify or implement a way of using this ourselves. This is the Espotek Labrador on PCBWay's website. And you can see it is an open source project, so open source hardware and software. You can download the source code. This is the specification. So it's a 2-channel oscilloscope, it's a waveform generator, it also is a power supply, low powered logic analyzer with serial decoding and a multimeter. It mentioned in the software here, show you this was on the PC, but you can also run this on Android as well, on a mobile phone. And the links are here, and this is your specification. So this is 100 kilohertz bandwidth, which is okay for audio repair, and it's quite an inexpensive device. But I will try to see if it works on VRMs like the other little oscilloscope I tried, which was specified at 200 kilohertz but was actually working up to 1 megahertz and still showing a signal. You can see the Labrador was designed to be used in this sort of manner for inventors, makers and students. So to connect it up for repair work, I'm going to have to make some changes to this, which I'll talk about again in a moment. And lastly, this is the pin out for the device. So we can see we've got 2-channel signal generator, either AC or DC output. And we have 2-channel oscilloscope, either AC or DC input. So we have channel 2 here, AC DC, we have channel 1 here, AC DC. And the duplicate pins, it goes on to mention, are just for measuring resistance and capacitance. But I'm going to assume you've all got a multimeter, so I'm not going to worry too much about those. I'm going to try and attach oscilloscope probes to this in a little enclosure so we can try it for repair work. I did notice in the software it was mentioned that the signal generator, you normally connect the output to wherever you want to inject a signal, and also connect it to the oscilloscope inputs so that you can actually see the waveforms that you are injecting into the device under test. So to use this in a little enclosure, we really need to be able to attach 2 probes, preferably oscilloscope probes, and be able to use one or both as an oscilloscope input or as a signal generator output. So thinking on that, I'll show you what I have in mind. This is the little €20, €30 oscilloscope we were trying last week. I'll link the video to this one. And this device proved itself to be very good actually for repair work in most cases. It was working way beyond the specification that is stated for it, And I was using this, for instance, to test VRM phases we're running at 350 kilohertz, where this supposedly has a 200 kilohertz bandwidth, and it was doing that sort of thing perfectly. So I really need to find a way to connect this in a similar way that we were connecting this. And here's my idea. This little box is a scrap Android box. I've taken the bottom off it, and we have the Android PCB, which I've also taken out together with its little Wi-Fi adapter. And I now have an empty little box, and this is fine. I mean, I can put this inside here. I can just stick it down with a bit of tape somewhere. And then I need a way to fit some BNC sockets I can drill here. And I'm going to need some switches so that I can switch the inputs to either be AC or DC for the oscilloscope, and I can switch them to be used as outputs for the signal generator. So I have a couple of these BNC connectors salvaged off something or other at some point, and I have some switches, little toggle switches. So let me draw out how I think I can adapt this, and then let's see if it actually works once we put it together. I have some of these switches in my stash of stuff. I bought a bag of them cheap, I think, on AliExpress at one point, thinking they might be useful. And I've used one or two as well. So these switches are actually double pole, but really I think we only need single pole. But the thing with these is that they are on, off, on. So in the down position, the middle pole is connecting to here. In the middle position, it goes nowhere, it's disconnected. And the up position, it's connecting these two together. So it switches the middle pin to either end, but with an off position in the middle. And I think these are actually ideal for our little project. On our Labrador board, we have input pins. We'll do the oscilloscope first. So we have input pins, channel 1 AC, channel 1 DC, channel 2 AC, and channel 2 DC. Yeah, and we also have, for the SIG gen, this is your signal generator, SIG gen, we have 4 pins again, and we have again the same thing. So we have channel 1 AC, channel 1 DC, channel 2 AC, channel 2 DC. If we connect our switches so that we have the first switch, and that's the middle position that's off, yeah, here, and the second switch here, we can now select on one of the switches channel 1 AC DC or off, channel 2 AC DC or off, and we can connect these to our probes, oscilloscope probe, yeah? And we'll have 2 probes. So this probe is channel 2 and this is channel 1. Okay, now the signal generator, we want to be able to monitor on the oscilloscope. We do that to set up effectively the waveform and the frequency and the amplitude. So again, we can do the same thing. So with the channel 2, again, we can put the switch with the center off position. Yeah, we can do the same here. So we're going to use 4 switches. Okay. Yeah, that's that switch. Again, center off. So from here, we can go and connect this directly to channel 2. So now channel 2 can either be off on the oscilloscope or AC or DC, and it can also be off on the signal generator or it feeds the signal generator AC or DC out to our device under test. Yeah, and it also feeds the signal into the oscilloscope on channel 2. That looks good, yeah. And we can do the same with channel 1 as well. So we can just connect that there. So it looks like we have most of the combinations we would want here. For instance, we can use channel 1 as a signal generator being monitored by the scope. And if we have this set to off, we can use the other scope probe to monitor further in the circuit to see where our signal is going. That might be quite handy for audio repair to start with. So that's the way I'm going to connect it up. It's powered via the USB, so we don't have to worry about power supply. And really we have everything there we want. So let's fit our switches onto the front of the case, I think. Yeah, we can probably put the 2 switches, and then we can put the BNC connector next to it, and then we can do the same for the other one. And we can stick some labels on so we know what they are. That sounds like a plan, don't you think, guys? So I'll start by drilling some holes and fitting all the hardware into the case. We're getting somewhere now. So oscilloscope, signal generator, AC, DC off for channel 1 and for channel 2. Very ghetto this, isn't it? But it kind of does the job. So I've soldered some little pin headers onto the end of the wires. So we can just check. This is oscilloscope channel 1, DC towards the end. So we can pop this one in here. Yeah, that's gone in. This is channel 2. Again, the DC goes to the end, which is the black one. So that's that one in there. Then this is the 4 channels of the signal generator, and the white one is again the DC connection, and this actually goes in here. So we now have all our connections put together. So this can go in the middle somewhere, and we have one left, and that is ground. And I'll just check, but I think it's over here somewhere. We can have a look at the diagram to be sure. Yeah, there we have it. So we can see we have DC on the oscilloscope channel 1, we have DC on channel 2, we have the 4 here starting. I've actually put them back to front, so I'll just fix it now. I'm looking at it. So channel 1, channel 2 DC goes to here. Yep, you can't see me doing it, I'm just turning it around the right way. Okay, that's that sorted, and we're ready to go. Oh yes, ground. So the ground is over here. Okay, there we have it with the ground. I noticed I had the 2 of these the wrong way round, so I just cut the pin header into 2 sets of 2 and then pushed them into the right place. Here's the Labrador powered up in my little makeshift case. So we have switches 3 ways, which are up for AC, center for off, and down for DC. This is channel 1, oscilloscope and signal generator, and then we have channel 2, oscilloscope and signal generator. I put the BNC connections on the side. There wasn't enough space on the front to fit them really, so I put them on the side. I haven't labelled them, I will do, but this is channel 1. Let's have a look at the software on the PC, and let's have a little play with this and see how useful it's going to be. I'll just launch the software. This is actually on the test PC, which has Windows 10 on. I tried this on my Windows 7 machine, and it supposedly does run on Windows 7, but I got an error. But to be quite honest, I have some problems with my Windows 7 machine, the one that's used for recording. I need to reinstall the operating system really, or put Windows 10 on. It's having issues with other programs as well, so I wouldn't take that as being generally a problem. I think it's just my PC. So this is the Espotek software. I have both oscilloscopes switched off at the moment, and the signal generators are also switched off. So let's put the oscilloscopes on DC, 2 of them, and let's see if we can get anything out of this. I'm just going to touch the probe. Yes, that's 1 channel. Oh, I see. So channel 1 is actually switched on and channel 2 is switched off. So let's go to channel 2. Channel 2. Yeah, we have both channels now. Okay. Yellow one and blue one. So the blue one is in fact channel 2 and the yellow one is in fact channel 1. Be nice if they put a yellow coloured box here, but I'm sure we know which is which anyway. Let's have a look. So we have a signal generator as well, and you probably can't see it very clearly the way I have it set up, but here I can set the frequency, the amplitude and the offset and the waveform. So I'll leave it on what it's set at. It's set on 1 kilohertz at the moment, so we'll just leave it on 1 kilohertz. Okay, amplitude we'll put 1 volt. Why not? We'll put 1 volt on both. Okay, we have 1 volt on both. Now, if I switch the signal generator on channel 1, you can see we have a signal there, and channel 2 is there. So we actually have 2 signals. That's AC coupled, DC coupled. AC coupled, DC coupled. Okay, you notice it's moving along. I need to set the trigger, so that's here. I just choose trigger, basically, and I can choose channel 1 or channel 2, rising or falling, and I now have a level where I can set the trigger level, so I have a stable waveform. Let's put channel 1 back onto AC, yeah. So we have 2 waveforms there. Now I was thinking with this, I can probably use this to inject a signal on channel 1 and view the signal. So let's switch this one off for a moment. Okay, so I've set the signal generator to DC and the oscilloscope channel 1 to DC, and we have it displayed on the screen there, and it's telling me at the bottom, you might be able to see it, frequency 1 kilohertz is waddling around a little bit. But we have that, and on channel 2 at the moment we have nothing because it's switched off. So let's go on to DC on here, and we get a little bit of crosstalk. You see a small waveform. That's probably to do with the way I've wired this up. I've not used screened wires, that might help. But anyway, we should now be able to, in fact we should now actually be injecting a signal on channel 1. I'll just untangle the wires. So this oscilloscope probe is on channel 1, and this should have the signal on it. So if I connect the other oscilloscope probe on channel 2, I should be able to see that signal. Yeah, in fact it is, it's going straight down to it, it's overlapping, it's the same. I'm sure I can make that, for instance, AC, so it'll float a bit higher, we'll see it. So generator 2 is off, oscilloscope is now on AC. Let's have a look. Yeah, and there's our signal coming back out. And obviously I'm just connecting the wires together. But what I'm thinking with this is, now I have a signal injected on this, and I can see it on the screen. I have this other probe. I can inject this into the input of an amplifier, audio amplifier, and probe around with this one and see what is happening to the signal, which is really handy for tracing amplifier faults. Let's see if I can probe some waveforms on the motherboard. We tried this with the other little oscilloscope, and we tried to read or measure the signal on a VRM, see if it was oscillating or not. So let's try that with this little oscilloscope. Now, technically speaking, this shouldn't have worked on the other one because the frequency is well out of the range. But we can give it a go. So we'll need to just switch our little switch to do this. So signal generator is now off, and I'm on, you can see, the yellow one, which is channel 1. I've grounded the board. So let's have a look to see what we get. Let's have a look. So I'll try and measure a VRM. Well, I can certainly see it's oscillating. I mean, that's for sure. I can certainly see it's oscillating. Let's change the attenuation. So let's take it down to 1/10 of what it is. I'm not sure. In fact, that's on channel 2. Let me do this on channel 1. So I've hit divide by 10, which will give us a smaller signal. Let's have a look again and see what we've got on the VRM. Yeah, I mean, absolutely, I can see that that VRM is running at 350 kilohertz. So this little tool is actually quite handy again. It's doing more than I would expect it to do for the specification of the device. Once again, I had a little play around with something that turned out to be rather more useful than I thought it was going to be when I first saw it. This is quite a handy way to use it. I mean, I just used some old switches and a couple of old BNCs. So it didn't cost a lot of money to do it. The possibility of signal tracing in amplifiers and audio circuits, I think, is definitely something that I should pursue. And yes, you can do it with a signal generator or even an output from your sound card on your PC and an oscilloscope. But this is a kind of an all-in-one solution with two probes, literally. You can dab around the circuit, and I think that's got to be tried. We can use AC coupling with this, with the signal generator as well. So effectively, we can not affect the DC condition of the amplifier when we're injecting a signal. Plus, having the capacitor on the input protects this device from any voltage coming back from the amplifier. So I think it's quite safe to do so. The other point is that this little oscilloscope only handles up to 20 volts on an input. But with these probes, we have an option to go to times 10. And effectively then you can probe up to 200 volts, which would be more than enough even if we're trying to measure the waveform on the output of an amplifier, even a very powerful one. So I have no qualms in doing so, and again we can use AC coupling on the input as well on the oscilloscope, again protecting the device from DC offset voltages. So I'd be very happy to try that. Now, I did say I'd try one other thing with this when I mentioned it on another video, and that was to see if it works on the Android phone. So I'll install the app on my phone now, and let's just see how it's working on the phone as well. You know what, guys? I was going to do that, but I've realised the phone has a USB-C type connector, and I don't have a suitable lead with the micro USB on the other end to even connect it to my phone with. I'll have to go and buy a lead to do that. I'll certainly be doing some more reviews with PCBWay's kit. I mentioned at the start of the video that I'd invited people here, subscribers, to be involved with some projects, building little gadgets like this and getting the PCBs made for us. And I'm sure we're going to be going down that route. So maybe once every month or two we might be able to build something. I think it'd be a good amount of time, really. And so what I will say, if somebody wants to see this working on the Android, I will have to go and buy a suitable lead, and I will try it. I will definitely try it. To wind up, I'd just like to say thank you to PCBWay for sending this little gadget and offering to sponsor this video, giving us a chance to have a play around with this. And I think we have something quite interesting here. I'd also like to say to the rest of you guys, if you have any interest in getting involved in building projects and making your own little bits of test gear in particular, then come over onto the Discord server. There's a few of us there already discussing this, and I'm sure between us we can come up with some really innovative ideas, and PCBWay will sponsor us in that, so they will build us the PCBs and help us in those projects. Lastly, I'd just like to say I hope you enjoyed this video, and sure you'll see me soon on another Word Electronics Repair video. So for now, one thing left to say really, and that's adios amigos.